Let's find all the rational roots of f and then use the depressed equation to find all roots of the equation f of x is equal to 0. So first we need to find all the rational roots of f. If it's asking us to find the rational roots of f, what it's asking for is the p over q process, where p represents the constant term, which for this equation is a 5. Q represents the leading coefficient, which for this equation is a 1. All right, so your numerator, think of it, the last number over the first number is how I think of it. And what you want to do is you want to find all factors of those numbers. So in your numerator, we have a 5. All factors of 5, well, are just 1 and 5. Those are the only numbers that multiply to get 5. The only numbers that multiply to get 1 is a 1. So then what you do after this is you take every number in the numerator, put it over every possible combination in the denominator. 1 over 1 would be a 1. 5 over 5 would be a 5. We also need to take signs into consideration. We're going to be taking the positive and negative of each one of these. So the possible rational roots are positive 1, negative 1, positive 5, and negative 5. In order to find our first root of our polynomial equation here, we need to do synthetic division and test some of these numbers here until we find one that works. So let's start with a positive 1 and see what that gives us here. If I'm going to do synthetic division with positive 1, drop down your coefficients for your polynomial. 1 for the x cubed, negative 7 for x squared, a positive 9 for x to the first, and a positive 5 for our constant. Drop down the 1 and multiply. 1 times 1 is 1. Add this column to get negative 6. Multiply again. Negative 6 times 1 is a negative 6. Add this column here to get a 3. 3 times 1 is 3. And when we add this column, we get an 8. What we're looking for here is we need a 0 in our remainder spot. Keep in mind the rightmost column here represents our remainder column. So this number down here in the bottom right corner is our remainder for this. We are looking to get a 0 here in order for the number that we test to be a solution, to be a root here. So the fact that we got an 8 means that 1 is not a solution to this equation. So positive 1 is out of the question. We need to then test negative 1, positive 5, negative 5, in whatever order you want. We're just looking for one of these to work. So I'm going to move to positive 5 and try that one next. We're testing positive 5. So using our coefficients, 1, negative 7, 9, and a 5, let's do synthetic division all over again. Dropping down the 1, let's multiply and add. 1 times 5 is 5. We add here to get negative 2. When we multiply, negative 2 times 5 is a negative 10. When we add here, we get a negative 1. Negative 1 times 5 is a negative 5. And when we add this column, we get a 0. That is exactly what we are looking for. The fact that we get a 0 tells us that 5 is a root. It is a solution to this function. So x does equal 5. That is our first solution. To get our second and third solution, again, this is a cubic, so we should ideally have 3 solutions to it, with the first being 5. Use your synthetic here to write your depressed equation here. That is going to be 1x squared minus 2x minus 1 is equal to 0. Solve this equation. Now, this is a quadratic equation, and typically the go-to method to solve a quadratic equation is going to be to factor. So let's see if this factors. Well, let's see. X times x would give us x squared. 1 times 1 would give us this 1 here. Looking at our signs, though, we know we need to have different signs based off of this negative. If your last number is negative, these are going to be different. If this last number is positive, these signs are going to be the same. Now, whatever sign the middle term is, that tends to go with a bigger number. Now, both of these numbers are the same. All right, so technically it does not really matter in this situation which one has a plus, which one has the minus. But if we double check this, positive 1 times negative 1 is a negative 1. But positive 1 plus negative 1 is a 0. We should be getting a 2 when we do that. They should multiply to get the last, add or subtract to get the middle. That is not working out here. This problem is actually not factorable. And since it's not factorable, we're going to go ahead and throw this into the quadratic formula. That means A is going to be 1, B is going to be our negative 2, and C is going to be our negative 1. So, quadratic formula, negative B plus or minus the square root of B squared minus 4AC all over 2A. Simplifying this, double negative rule makes out a 2, plus or minus the square root of negative 2 times negative 2 is a 4, negative 4 times 1 is a negative 4, times a negative 1 makes that a positive 4, over 2 times 1, which is 2. Add underneath the radical to get 2 plus or minus the square root of 8 over 2. Simplifying the square root of 8. Keep in mind the square root of 8 is the square root of 4 times the square root of 2. Square root of 4 is a perfect square. That gives us the 2. Square root of 2 just drops down, giving us that the square root of 8 is 2 square roots of 2. Throwing that in here, that gives us 2 plus or minus 2 square roots of 2 over 2. Reduce your fraction. Divide everything by a 2 to get here 2 divided by 2 is a 1, plus or minus 2 over 2 cancels out to a 1, and 1 square roots of 2 is just square roots of 2. Over 2 divided by 2, which is a 1, which is insignificant here. So our second and third solution, 1 plus or minus the square root of 2, and don't forget that we had that x equals 5 here.